My name is Connie Lawhead. I'm the president of Deschamps Technologies, LLC. The founders of Deschamps Technologies combined have over 60 years of experience in the HVAC market. Now, with 60 plus years of experience, we have seen or experienced many challenges with HVAC equipment. A perfect example is an issue that has plagued the industry for many years, and that's the standard P-trap. Now, we have taken an idea, we've developed it, we've patented it, and building it in-house to solve this very issue. We have two traps. One is a positive pressure waterless trap, the P series, and the other is a negative pressure waterless trap, the N series. Now you may ask, why are your traps better than the standard P trap? There are many advantages to our traps, which in the following video we will go into greater detail about the functionality, the advantages, and ultimately the installation process. But let me highlight a couple I think are important. The first being that since our trap operates dry, there's no standing water, so freezing traps goes away. Another important advantage to highlight is the reduction of sludge buildup that you see in a standard P-trap. The third advantage I would like to highlight is the reduction in space required. Now, the standard building code for a standard P-trap states that from the drain connection down to the first 90-degree bend should be double the plenum pressure. In many cases, mechanical contractors have to install roof curbs, or I have even been told drill through roofs in order to get the proper installation. We state that approximately 50% reduction in the required space to install our traps. And it's very simple. Our traps do not require double the pressure in order to function properly. Now, when you review the following video, you're going to see a lot more detail on all of the advantages. But after reviewing the video, if you have any questions, please do not hesitate to go to our website, which is www.deschampstechnologies.com, or send an email to info@deschampstechnologies.com. Thank you.
We're now going to talk about the Deschamps Technologies LLC negative trap. It's a simple device. It involves a ball and a seat that is the valve, serves as the valve. Now, the object of this product, this negative trap over a P-trap, is number one, and very important, it requires half the height or less that a P-trap would require. Basically, it's installed horizontally, 2 inches in diameter, and if you had 6 inches of negative pressure, you would only have to have 6 inches up from your drain line to the trap. So you could normally get by without having to have a curb. If you were to be putting a packaged unit on a concrete slab, for instance, you wouldn't need to put a curb under it unless you wanted to. It would only require a standard 8-inch curb on the unit itself or frame. That's a big advantage. The second advantage is when there's no condensate flowing, the trap is dry. So in the winter, there's very little chance of freezing, if any, depending upon how you installed it. The third is a very important feature also. On many systems, the unit sits during the winter months, could easily dry out, or even at startup when the unit's first installed. When you turn the fans on, fans are going, condensate forms, Well, the airflow sucking back up into the unit with a dry trap causes water to fly all over the place, sort of a geyser effect, and gets the insulation wet, the fans, the motors. It's a big mess. I've had it happen to our products many times. And the fourth is, since it operates dry most of the time, except when condensate's forming, there's much less chance of any crud buildup in the trap like you would normally have in a P-trap at the bottom of the loop. This should stay relatively clean over a period of time. So, they're the advantages, 4 major advantages of the Sham dry trap as opposed to a P-trap. Now I'm going to run the test. First, I'm going to turn on the shop vac, which creates any pressure I want, negative pressure that I want, but I'm running it at about 2 inches, which is typical of an HVAC unit on the suction side of the fan. So, first I'm going to turn on the fan, then I'm going to turn on the water, which would be the condensate forming once the unit's in operation. So here we go. There's the trap. Okay. First I'm going to turn on the fan. It makes a lot of noise, that's why I'm turning it. Okay, there's no water flowing, so with the fan going, it sucked the ball up against the seat. Okay, this is the ball right here. That's the seat. Okay, now I'm going to turn on the water, which would represent condensate flow, and you will see the ball move away from the float, the seat, and it's running at about 1.6 gallons per minute. This trap will pass 4 gallons per minute, but like I said in the positive display or demonstration, 1.6 gallons per minute is equivalent to 67 tons of latent cooling. Okay, you can see the pressure. It's about 1 3/4 inch pressure drop, negative pressure drop. Okay, the ball is away from the seat. Now I'm going to turn the water off, which represents no condensate flowing anymore. Now, as the water goes down, the ball's going to work its way to the seat. The water's got to get out of the standpipe. It's kissing it now, but in a minute it'll suck up against it and hold like it is now. Now a little air is leaking around that trap, and eventually the water will all dry. It'll probably take a half hour for all the water up in here to dry out, but you're leaking probably 0.1% of the air that would normally go through a trap with a dry trap, 0.1% or less. You can't feel any suction at the end of the drain line with your hand. Okay? Now, it's pretty a simple trap. You just have to make sure you put it in horizontal. This ball has to work its way against the seat, and it's on a rail. If it's sloped too much in the opposite direction, the ball, even with a high pressure and a high flow rate, is not going to suck that ball up. So it has to be installed horizontal, or if anything, sloped a little bit toward the incoming water flow. Okay, that's it for the negative trap. I'm going to sign off.